students, welcome to my channel. In this class I am going to teach you helix. I will give you the definition of helix and I will prove an important theorem on helix. So let us start the topic. So first of all, definition of a helix. A helix is a space curve which is traced on the surface of the cylinder and cuts the generator at a constant angle. A curve which lies on a cylinder and cuts the generators at a constant angle is called a cylindrical helix. So, I am given here two types of a definition. The first one is this: a helix is a space curve which is traced on the surface of a cylinder and cuts the generator at a constant angle. Or you can write a curve which lies on a cylinder and cuts the generator at a constant angle is called cylindrical helix. So now the important theorem which is related to helix is a necessary and sufficient condition for a curve to a helix is that its curvature and torsion are in a constant ratio. That we have to prove. Proof of necessary part. In this part, let us suppose that the curve be a helix and we have to show that the ratio kappa by tau is constant. Curvature by torsion is a constant. Let a cap be a unit vector along the direction of the helix. I have taken here it is a cap be a unit vector along the direction of the axis of the helix, and a t cap be a unit vector. Here a cap that I have taken a unit vector along the direction of axis is also constant. By definition, helix intersects the generators at a constant angle alpha. Then we have t cap dot a cap, the scalar product t cap dot a cap is equal to cos alpha constant. Now differentiating both sides with respect to s arc length s, we get t cap dashed a cap is equal to 0. But by Serret-Frenet formula we know this is kappa n cap. Kappa n cap dot a cap is equal to 0. So this implies n cap dot a cap is equal to 0 as kappa not is equal to 0 or helix. This implies a cap is perpendicular to n cap. That is, a cap lies in the rectifying plane. That is, a cap lies in the plane containing vector t cap and a b cap. Here we have taken this is vector a cap lies in the rectifying plane containing t cap and a b cap. As vector a cap makes an angle alpha. So here a cap makes an angle alpha with the t cap. Then clearly it will make an angle 90 degree minus alpha with B cap. So we can write vector A linear combination of T cap and a B cap. That is equals to cos alpha T cap sin alpha B cap. So vector A cap is equal to cos alpha T cap sin alpha B cap. So now differentiating both sides with respect to arc length S, we get 0 is equal to cos alpha T cap dash sin alpha B cap dash. So we get 0 is equal to cos alpha T cap dash sin alpha B cap dash. T cap dash by Serret-Frenet formula is equal to kappa n cap cos alpha. This is B cap dash is equal to tau n cap sin alpha. 0 is equal to kappa cos alpha minus tau sin alpha into n cap. As n cap not equal to 0, then cos alpha kappa cos alpha minus tau sin alpha is equal to 0. This implies kappa cos alpha is equal to tau sin alpha. So this implies kappa by tau is equal to sin alpha by cos alpha is equal to tan alpha is equal to constant. So this proves the necessary part of the theorem. This proves the necessary part of the proof of sufficient part. So before going to prove sufficient part, I'm just going to give the explanation behind it. Here after differentiation we are getting T cap dash into A cap is equal to 0. This is kappa n cap dot A cap is equal to 0 by Serret-Frenet formula. Because we know in a Serret-Frenet formula T cap dash is equal to kappa n cap. So then kappa not equal to 0, so n cap dot A cap is equal to 0 means A cap perpendicular to n cap. A cap lies in the rectifying plane. This is called rectifying plane containing the plane T cap and a B cap, tangent and a binormal. That means A cap lies in the plane containing T cap and B cap. So here alpha is the angle made by A cap with T cap, and a 90 minus alpha is the angle which is made by A cap with B cap. Now clearly A cap can be expressed as a linear combination of a T cap B cap. So we can write cos alpha T cap sin alpha B cap. So this is the length. Suppose unit length is this. Here we are taking O. Now O, this is P suppose, and this is B suppose. So here we get OB vector is equal to P vector plus PP vector. So cos alpha T cap sin alpha B cap. Now differentiating both sides, because cos alpha sin alpha both are constant, so we get 0 is equal to cos alpha T cap dash sin alpha B cap dash, and we are using T cap dash is equal to kappa n cap cos alpha, B cap dash is equal to tau n cap sin alpha by Serret-Frenet formula. A T cap dash is equal to kappa n cap, B cap dash is equal to minus tau n cap by Serret-Frenet formula. Now we are taking n cap common here. Now n cap is a unit vector not equal to 0. So this expression is equal to 0, from which we are getting kappa by tau is constant. So this proves the necessary part of the theorem. Let proof of sufficient part. Let kappa by tau is equal to constant is equal to tan alpha. See. So this implies kappa by tau is equal to sin alpha by cos alpha. So this implies kappa cos alpha minus tau sin alpha is equal to 0. So this implies kappa n cap cos alpha tau sin alpha n cap is equal to 0. So this implies T cap dash cos alpha plus B cap dash sin alpha is equal to 0, as kappa n cap is equal to T cap dash and a minus tau n cap is equal to B cap dash. So these can be written as d by ds of cos alpha T cap plus sin alpha B cap is equal to 0. So now integrating both sides, we get cos alpha T cap sin alpha B cap is equal to constant is equal to A cap C. So cos cos alpha t cap sin alpha b cap is equal to constant we get. Then multiplying with t cap cos alpha t cap plus sin alpha b cap is equal to vector A dot t cap. So this equals to cos alpha t cap dot t cap sin alpha t cap dot b cap is equal to vector A t cap. This is equal implies cos alpha into 1 sin alpha into 0 vector A dot t cap. So this gives us vector A dot t cap is equal to cos alpha. This so that a curve makes constant angle with the direction, so the curve is a helix. The curve makes constant angle with the direction, so the curve is a helix. This proves the sufficient fact of the theorem. Hence proved. So the theorem is now completely proved. The topic for today's class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.